All right, now we're doing page 4 of the practice test, and there will be a problem very similar to this on the final exam for this 6.2. Remember, if they give you the percent composition, the first thing remember we do is essentially assume we had 100 grams of substance, so we change percent to grams. So 49.48% carbon, I will say 49.48 grams of carbon, and then 5.19 grams of hydrogen, 16.48 grams of oxygen, and 28.85 grams of nitrogen. The next thing I'm going to do is divide by the molar mass to turn this to moles, okay? So we want to do grams to moles. We know that carbon has a molar mass of 12.01. That's how much the mass per mole of carbon is. The grams divide out, and now I will have moles of carbon. Hydrogen, molar mass of 1.10, or 1.1, sorry, per mole of hydrogen. That will give me moles of hydrogen. Oxygen we know is 16.00 grams of oxygen per mole of oxygen. That will give me the mole of oxygen. And finally, nitrogen is 14.0 grams, 14.01, apologize, grams of nitrogen per mole of nitrogen. So on this, 49.48 divided by 12.01 is 4.1199. We're going to say 4.12. Round to the nearest tenth. Next we have 5.19 divided by 1.01. 5.1386, we'll say 5.14. 16.48 divided by 16, we'll say 1.03. And finally, 28.85 divided by 14.01, 2.06 moles of nitrogen. Okay, third step is we divide by the smallest number to simplify the ratios. We're doing that to simplify the ratios. The smallest number here, amount of moles, is 1.03. The smallest amount of moles. So I'm going to divide everything by 1.03 to simplify the mole ratio. 4.12 divided by 1.03 is 4 moles of carbon. 5.14 divided by 1.03 is 5 moles of hydrogen. This, of course, is 1 mole of oxygen, and then we have 2 moles of nitrogen. Now, these numbers, these are kind of nice because they are all whole numbers. These are our subscripts. So our empirical formula is C4H5O1, and I don't put the 1, it's understood, and N2. That is my empirical formula. Now it says the molar mass is 194. So now I need to figure out what that adds up to. 4 times 12.01 plus 5 times 1.01 for hydrogen. 1 times 16. And I know that this is 48.04, and this is 5.05, and then finally 2 times 14.01. When I add up all of these together, I get 97.11. That's the mass of a single empirical formula. So I take my molar masses of the substance, and I divide it by the molar mass of one single empirical formula, and that I end up getting 2. So now that is my multiplier. So I take 4 times 2, 5 times 2, 1 times 2, and 2 times 2. So that is my molecular formula for caffeine.